Dear participants, good morning. We with pleasure to announce the second Grabchenko's International Conference on Advanced Manufacturing Processes is opened despite many other problems in the global world. This year has become a real challenge to all of us to organize conference in a principally new format. And in my opinion, we have successfully solved it. The thanks to all team members, to all participants for your contributions and patience. I would like to give a brief overview about InterPartner Conference Series. Our conference focuses on promoting research and development activities, intensification of scientific information interchange between researchers and engineers. Next slide, please. The conference is, next slide. Next. The conference is organized by Odessa National Polytechnic University, National Technic University Kharkiv Polytechnic Institute, Sumy State University, and International Association for Technological Development and Innovation. Association for Promoting Innovative Technologies from Croatia, as well as Springer, is a chair on strike plagiarism companies. Unfortunately, I can host all of you in Odessa as usual. Due to the COVID-19 pandemic situation, the conference moved online and broadcasted worldwide from the webinar studio of Sumy State University. I would like to pay your attention that all sessions will be saved and will be available to everyone. Our next slide. Our history starts in 1991 in Kharkiv Polytechnic University. Professor Grabchenko initiated the first InterPartner seminar on the problems of cutting materials and cutting tools. From 1991 to 2013, the seminar was held in Crimea. Since 2014, it has been held in Odessa. During this time, more than 3,000 scientific reports were presented by scientists from 39 countries. Published 63 volumes of scientific works. Since 2018, the proceedings of the conference have been published in the Springer Publishing House, lecture notes in mechanical engineering. Next, please. Which is indexed in Scopus. 63 speakers from 12 countries of the world were represented as at InterPartner 2019. At InterPartner 2020, we expect the submission of 87 reports by 268 answers from 13 countries. I would like to pay attention to the participants that extended versions of your research can be published in our partners' journals using fast track option. Next slide, please. Next. We plan that the online meeting in 2020 will take place over 2 days on September 9 and 10. There will be 6 sections in which all submitted reports will be considered. Next slide, please. Next. Okay. You see agenda for today and tomorrow now. Next. I would like to thank members of the scientific committee and invited external reviewers for their efforts and experts in contributing review, without which it would be impossible to maintain high standards of pre-reviewed papers. They devoted the time, energy, pre-reviewed and manuscripts. Our reviewers come from all over the world and represent 29 countries and affiliated with 63 institutions. Thank you very much to InterPartner team. The involvement, hard work were success of the conference. Let me introduce now our honorary chair of the conference, Professor Anatoly Ivanovich Grabchenko, National Technical University, Kharkiv Polytechnic Institute. Please.
Уважаемые участники конференции, позвольте от всей души поздравить вас с новой встречей, с новыми надеждами. Позвольте сердечно поздравить вас с возможностью встретиться, обменяться впечатлениями, определить новые задачи и новые рубежи. Эта встреча должна принести новые результаты, новые успехи, новые связи. Сердечно спасибо вам всем за добрую встречу, за возможность подвести новые итоги и наметить новые рубежи, новые уровни.
Thank you very much, Anatoly Ivanovich. And now, Rector of Odessa National Polytechnic University, Professor Gennady Oborsky.
Дорогие друзья, мы искренне рады, что в этом году наш традиционный интерпартнер все равно пройдет, несмотря на все негаразды, которые связаны с карантинными ограничениями. Эта конференция, этот симпозиум, это общение между друзьями, я не ошибаюсь, именно между друзьями, как вы знаете, было начато почти 30 лет назад. В 1991 году профессор Грабченко Анатолий Иванович, Харьковский политехнический институт, провел первую эту конференцию. Она традиционно 25 лет проходила на базе ХПИ в Алуште. За это время учеными было сделано 3600 докладов, опубликованные статьи поместились в 63 томах. Это просто явление в инженерной механике, в технологии машиностроения, в учениях по обработке металлов и не только. Это явление продолжалось довольно долго, развивалось. Если вы знаете, там практически все сегодняшние лидеры нашей отрасли, доктора наук, апробировали свои докторские диссертации. Там была отдельная специальная секция. Но, к сожалению, с 2014 года Алушта закрыта для нас. И Одесский политехнический, являясь, в общем, продолжателем и соучредителем этой конференции, принял на себя эту миссию, это почетная миссия. Мы с 2014 года проводим эту конференцию в Одессе вместе с Харьковским политехом и вместе со всеми участниками из многих стран. В принципе, за эти годы в нашей конференции участвовали иностранные ученые из 39 стран. И несмотря на разные перипетии последних лет, в прошлом году у нас были доклады из 63 доклада из 12 стран. Это Италия, Испания, Польша, Словакия, Грузия, Сербия и другие. Особенностью нас, мы все-таки как бы тоже решили привнести какие-то креативные нотки в развитие нашего интерпартнера, нашего совместно с харьковчанами интерпартнера. И усилиями Политехнического университета, в частности Владимира Михайловича Тонконогова, доклады и статьи, которые наши ученые представляют на этой конференции, уже второй год попадают через издательство Springer в журнал, который индексируется в Scopus. То есть все доклады, прозвучавшие в 2019 и которые будут произнесены в 2020, попадают в Scopus. Я считаю, что это очень серьезная победа, и она, на мой взгляд, должна привлечь еще большее внимание наших активных ученых, и не только нашей страны, но и зарубежных стран. Мы горды тем, что Одесский политехнический продолжает традиционно интерпартнер. Желаю всем успехов, не останавливаться, заниматься наукой, растить молодежь и в добрый путь.
Thank you very much, Gennady Alexandrovich. And this concludes our opening ceremony. Thank you all for your participation. And I announce that the first keynote session will be start now. So, I am very happy and honored to me to provide the first keynote session. Firstly, I would like to present our plan. We have three very important keynote speeches. At first will be Professor Vitaly Ivanov from Ukraine. Is present, Vitaly? Okay. The second will be Professor Dagmar Kaganova from Slovakia. Is present? I see. Okay. The second and third speech we will be from Milan Edu from West Bohemia University, Czechia. But at first, I would like to say a few words about Professor Vitaly Ivanov. Vitaly Ivanov is a Doctor of Science in Engineering and head of the Department of Manufacturing Engineering, Machines and Tools at Sumy State University. Dr. Ivanov's research activities concern fixture design, computer-aided technologies for manufacturing engineering, multi-axis machining of complex parts, augmented reality for manufacturing and education, innovations for engineering education. Now he is ready to deliver a keynote speech on the following topic: manufacturing, technology for complex parts machining. Dear Professor, Internet, Skype is yours. Please, you can start.
Thank you very much. Good morning to everyone. Good morning to all participants. And thank you very much to Professor Vladimir Tonkonogi for kind introduction. I appreciate the invitation, and it's a great honor for me to accept it and to deliver the keynote speech during this session. I would like to start my presentation from a brief overview of my city and the university. Greetings to all participants from Sumy State University, and as you know, Sumy, my native city, and it is located in the northeastern part of Ukraine. To be honest, it's not easy to get us, but it's worth it. And as you can see, it is a beautiful green city. Furthermore, I am pleased to invite you to visit us in 2022 during International Conference on Design, Simulation, Manufacturing, the Innovation Exchange. Slide 5, please. The key directions of Sumy State University are research, education, and internationalization. Therefore, we have more than 230 partners from 96 countries. Together, we realize their research and educational projects with universities from 45 countries, as well as establish academic mobility programs with universities from 39 countries. Sumy State University is represented in several rankings, for instance, QS, Times, Webometrics, etc. Our latest achievement is the position of 501/600 and the first and the second position among Ukrainian universities in the ranking of the World University Rankings by Times Higher Education. The main campus is in Sumy City, but we also have two extensions in Shostka and Konotop. I represent the Faculty of Technical Systems and Energy Efficient Technologies, which is the oldest faculty at university. We started our history as a branch of Kharkiv Polytechnic Institute and became Sumy State University in 1991. Now faculty consists of 8 departments and 6 research centers and laboratories. The capacity is a little bit more than 100 academic staff and more than 800 students. The Department of Manufacturing Engineering, Machines and Tools has a long history. Next March, we will celebrate the 55th anniversary. During the last 30 years, the department was chaired by Professor William Zaloga, and we highly appreciate his significant contribution to the development of the department. Now I am responsible for the capacity building of the department, and the department has changed focus, and now we are strictly oriented on internationalization based on fundamental and applied research. We have experience of participation in projects funded by European Union, DFG, DAD, JICA, Czech Development Agency, NSP, etc. We collaborate with universities from 16 countries. Our strategic partners are Technical University of Košice, Poznan University of Technology, University of West Bohemia, Kielce University of Technology, University of Duisburg-Essen, Slovak University of Technology in Bratislava, and others. We are implementing practice-oriented research, and that's why we collaborate with different industrial partners, both national and international. We have a successful experience in working in big consortiums. 5 projects funded by the European Union within Tempus and Erasmus Mundus programs, as well as Erasmus Plus, were realized during the last 8 years. Last March, a 2-year project funded by Gene House Foundation, United States, was started. This April, we initiated a 1-year project funded by DAD, as well as academic exchange with Turkish universities within Mevlana exchange program. We are open for collaboration, academic mobility, capacity building and innovation, education, professional training, joint research results. My report will be delivered according to the presented structure. Let us start with the major challenges in manufacturing. Manufacturing engineering is responsible for 70% of the entire global trade. Today, a major challenge is the contradiction between the need to reduce the time required to design and manufacture the products and the increasing complexity of product design. Over the past 25 years, the product range has increased more than 2 times. Constantly increasing their complexity, the demands for accuracy and product quality are increasing. The equipment and process should be more flexible to meet the needs of the market and reduce the amount of time to appear on the market. The essential point in manufacturing is an analysis of the technological system, machine tool, fixture, workpiece, cutting tool, as a closed-loop system where every component affects other components and the system as a whole. Traditionally, fixture systems divide into dedicated and flexible. Dedicated fixtures are designed for mass production. The design, fabrication, and testing of fixtures require significant time and cost in the product development cycle. To reduce the above-mentioned parameters, flexible fixtures were developed. The use of flexible fixtures enhances fixture flexibility, which is especially beneficial to small volume production and new product prototyping. According to annual reports from different countries, the most in demand are drilling, milling, boring machine tools. Analysis of the structure of this equipment allows us to make the statement: machining centers are the first priority equipment for modern manufacturing conditions. The experience of the Japanese machine tool industry showed that 60% of new machines are drilling, milling, boring machine tools. 95% of them are machining centers. 91% of new machines are CNC machine tools. It's important. And the key points of motivation to buy machining centers are increasing productivity, updating technology, and increasing capacity. Analysis of more than 1,000 machine tools from more than 30 manufacturers allows identifying the most in-demand parameters of machine tools. There is a tendency for the investment in horizontal machining centers. Let's forward to the main content of the presentation. Slide 20. I'm sorry for technical issue. I will continue shortly. Next slide, please. Yes, this one. In manufacturing engineering, a large number of parts need to be machined. Complex parts are the parts with complex spatial geometric shapes and require multi-axis machining of surfaces with the ensuring specified size accuracy parameters. The accuracy of placement was restarted. Typical representatives of complex parts are forks, brackets, connecting rods, and levers. Complex parts are 36% of the total number of parts in manufacturing and 24% of the labor content of machining. Based on the problem-oriented analysis of parts and their systematization, the design and technological classifications were developed for such parts as forks, brackets, connecting rods, and levers. The design and technological attributes of parts were taken into account. The fork-type parts are characterized by a complex spatial geometric form, which causes difficulties in the locating and clamping of workpieces, and leads to the complexity of machining due to the increase in the number of setups. The typical manufacturing process for fork-type parts consists of 9 technological operations. 5 of them are drilling, milling, boring operations that require 7 setups of the workpiece during the machining. Based on the technological capabilities of modern multi-purpose machining centers and the tendency to the intensification of manufacturing processes, it is proposed to develop an approach for multi-axis machining of fork-type parts. Following this approach, the operations 1535 should be combined in one operation. It allows reducing the manufacturing process by 4 operations, ensuring the reduction of equipment units from 5 machines to 1 machining center, and the number of fixtures from 5 dedicated to 1 flexible fixture. comparative analysis of structures of manufacturing process for labor content confirmed substantial reduction of time costs, in particular the auxiliary time in 2.3 by times and the preparatory time in 4.1 by times. Comparative analysis of the machining time confirmed the significant increase of cutting time from 52 to 67% due to the reduction of auxiliary time for fork-type parts. Similar research results were obtained for connecting rods from 23% to 39% and for lever-type parts from 17% to 40%. In multi-product manufacturing, it is important to ensure the efficiency of manufacturing processes for different batches. The key increase in performance is observed for changes in the batch size from 1 to 15 pieces due to the preparatory time. Thus, it is reasonable that the offered manufacturing processes allow increasing machining performance depending on the batch of parts. Forks from 1.3 to 2.3 by times, and connecting rods to 4 by times, and levers from 2.5 to 4.6 by times. To justify the structure of the operation, a graph defining the order of processing and interrelation between the processed surfaces in different positions of processing is developed and presented in this slide. To realize the accurate locating and reliable clamping during machining, the flexible fixture was developed. The adjustment mechanism of locating and clamping elements allowed to expand the technological capabilities of the machine tools and to ensure the setup of the group of parts and their multi-axis machining. This feature ensures the flexibility of fixtures. Many fixture configurations have been developed for the locating of parts on multi-purpose drill and milling machines, which provide parts machining in a certain range of sizes. Slide 27, please. Yes, fixture design process is a variable process that requires consideration of many parameters of the technological system. For one part can be offered various fixture configurations corresponding to all specified parameters. By their effectiveness for different production conditions will be different. It is reasonable that the efficiency of the manufacturing process to evaluate by a single economic indicator at the cost of machining, which considers the cost of time, the total cost for the implementation of the manufacturing process, as well as batch of parts. The results are evaluated using comparative cost effectiveness. It is proved that the scope of the effective use of flexible fixtures depends on the number of sizes. That is when the number of sizes increases. The flexible fixtures efficiency limit shifts in the right direction. Flexible fixtures efficiency is ensured in short-term machining. By increasing the share of the cutting time, the efficiency limit shifts to the left direction. Flexible fixtures the effect of the auxiliary time on the cost of machining for described manufacturing process is presented on the slide. Reducing auxiliary time costs has a positive effect on the flexible fixtures efficiency. The similar nature of curves has a preparatory time. Increasing this norm adversely affects the efficiency of the flexible fixture. Thus, an effective area of using flexible fixtures have been determined and practical recommendations have been developed. The comparative analysis of the typical and proposed manufacturing processes is performed for two cases: machining of single nomenclature and machining for group nomenclature of parts. The numerical modeling of the proposed flexible fixture confirmed compliance with specified strengths parameters and the elastic displacement of the fixture elements does not exceed the tolerance values. The investigation of involuntary oscillations under the influence of the system of forces that correspond to the unstationary components of the cutting forces and moments indicates that the maximum amplitude of displacements of fixture elements does not exceed the allowable values. To confirm the efficiency of the developed technical solution, experimental research of the results of numerical simulation on the definition of displacements values under the influence of static load is performed. Experimental researchers have shown the reduction of their oscillation frequencies by 8% compared to simulation results. Real eigenfrequencies exceed the cutting modes, so resonance does not arise. All dimensions of the lever parts are set within the set tolerances, namely the size of holes, center distance, and spatial placement of surfaces. The next part of my presentation is devoted to the process-oriented approach to fixture design. Fixture design is a complicated and time-consuming process. Therefore, the following fixture requirements were identified and should be taken into account during the design process. In fixture design for multi-product manufacturing, it is important to find the golden mean between flexibility and productivity, as well as to ensure the required accuracy. Using the regularity and export information should be used to convert input information to output. 1. 3 stages were identified for the fixture design process. The innovation of this approach is the separation of the investigated objects at the stages. So we have the stage 1, manufacturing analysis of the workpiece, the stage 2, synthesis of the fixture competitive variance and multi-criteria optimization, and stage 3, verification. At the first stage, the key functions are the identification of the functional surfaces, the choice of the locating and clamping chart of the workpiece, and generating of the manufacturing plan. The next stage is the synthesis of fixture configuration and structural optimization. And the detailed algorithm of the synthesis process is presented at this slide. As you can see, the generating of competitive variants for all types of functional elements are presented. And the final stage is generated of competitive variants of fixture configurations. Multi-criteria optimization can be realized using the method of successive concessions. Moreover, the method for spatial positioning of the fixture elements was proposed and patented. Verification of the fixture workpiece system is an urgent and important task. The foreseen research tasks were suggested to better evaluate the weak places in the fixture configuration during machining. Therefore, the process-oriented approach allowed to implement a comprehensive approach in fixture design, including design, synthesis and optimization, and verification. The next part of the presentation is devoted to software development. The suggested structure of the computer-aided fixture design system has 5 modules that operate according to the developed algorithm in stages. The key differences are manufacturing analysis of the workpiece, synthesis and optimization of the fixture, and verification of the system fixture workpiece. The implementation of the mathematical models is performed in the computer-aided fixture design working models, which include a model of the database management. The database ensures system functioning in sense of qualitative performance of its main functions, data search and update. It presents the main system support for selecting of the existing fixtures, modification, or design of new solutions by providing all necessary information. You can see the interface of the developed model of input data. The user can upload and fill in all required information. It allows accumulating information for further procedures. Competitive supporting locating and clamping elements were selected from the database. Moreover, after that, the list of generated fixtures competitive variants was formed in the model of synthesis. The next part of presentation is devoted to the augmented reality for fixture design. The up-to-date development of society and technology requires the preparation of highly qualified specialists for manufacturing engineering industry. The augmented reality technology was used for fixture design. It allows visualizing a 3D model of fixture based on 2D drawings. It will be efficient for manufacturing enterprises focusing on parts machining and assembly technologies. A new methodological approach aimed at the improvement of spatial visualization, understanding of the relationship between the 3D model, its drawings, and individual views have been implemented. For the first time, the augmented reality technology in fixture design has been introduced. The proposed approach is more productive than the use of traditional static axonometric images. The significant reduction in the time spent on training or maybe retraining of personnel for the industry is a reserve for the production efficiency. To sum up, the further development should be focused on the design and implementation of the intelligent fixtures, parameter identification using artificial intelligence, elaboration of the functional-oriented models, and the computer-aided fixture design integration with other computer-aided technologies. I am greatly appreciated to Professor Volodymyr Tonkanogy and InterPartner team for sharing the recent research results among participants. Thank you very much to my research team for their support, and much obliged to all participants. Thank you for your attention. Дякую за вашу увагу.
Dear Professor, thank you very much.
Thank you very much for this opportunity to be a part of InterPartner conference.
Maybe some questions from YouTube, from chat. No questions?
No, I didn't see questions in chat. Thank you.
Maybe everyone not wake up. No. Thank you, Professor.
Thank you very much. Thank you.
And next our speaker is Professor Dagmar Kaganova. Oh, I see you. Dr. Dagmar Kaganova is an associate professor in industrial engineering, ambassador representative for foreign affairs, faculty of material science and technology in Trnava at Slovak University of Technology in Bratislava. She is also the co-founder of the European Alliance for Innovation in Slovakia. Moreover, she is a grant holder of several Horizon grants funded by European Union. Today, her co-speakers will be Natalia Hornakova and Ladislav Morovets. Dr. Ladislav Morovets, who works as a vice head of the Department of Machining and Computer-Aided Technologies at the Faculty of Material Science and Technology in Trnava of the Slovak University of Technology in Bratislava, Slovak Republic. Dr. Morovets is an expert in design, machining, measuring, and 3D scanning of complex surfaces. Dr. Morovitz will join Dr. Kaganova and provide information regarding his recent research results. Dear Professor, I see you enjoy the internet and the Skype vision. Please start. We stay with you.
Good morning, dear ladies and gentlemen. Dear Professor Tonkonogi, thank you very much for your kind invitation. We sincerely appreciate, and I have to say that I have in my fresh memory beautiful memories from previous InterPartner, from the first Grabchenko's International Conference on Advanced Manufacturing Processes in Odessa. So thank you very much once more. So the title of our presentation is Linking Research and Innovation with Focus on Equalities. Firstly, next slide, please. Firstly, I would like to give you some short overview about our Slovak University of Technology, as well as about our faculty of Material Science and Technology. And after that, we would like to share our experience with Age 2020 projects. The first one with title Linking Research and Innovation for Gender Equality. And the second one, Directional Composite through Manufacturing Innovation. All three of us are actively involved in solving these Age 2020 projects. Next one, please. Slovak University of Technology in Bratislava, according to university rankings, is the best university in Slovakia. So we are really proud of it. And we are happy that we have a chance to collaborate with your Ukrainian universities. Our university offers education and scientific research in the area of engineering, as well as in the area of arts. And we have to say that our roots of our university go to theoretical practical learning method just directly to Mining Academy in Banská Štiavnica. And what I consider as really useful, I see especially in direct collaboration within industry and strong international partners. Next one, please. Our Slovak University consists of several faculties which are located in Bratislava. All of them, majority of them, 6 are located in Bratislava, and just our only faculty is located in Trnava. I will ask you for next slide, please. We have faculties like civil engineering, mechanical engineering, electrical engineering, and information technologies. And our faculty is Faculty of Material Science and Technology. Also part of our university are institutes, for example, Institute of Management and the Center of Lifelong Learning. We have also at our university, Slovak University of Technology, Research Center, Computing Center, Publishing House, and also we have area for concentrating on sport activities, Academic Sports Center. Next, please. Also, our faculty, as I already mentioned, is the only faculty which is located outside of Bratislava. Bratislava is capital, is located in Trnava, what is pretty close, approximately 30 minutes by highway. Our colleague, Ladislav Morovic, who is responsible for Decomposition project, Directional Composite, comes from Institute of Production Technologies, and my colleague, Dr. Natalia Horniakova, and me, we both work at Institute of Industrial Engineering and Management. But also other institutes of our faculty, the institute like Institute of Material Science, Integrated Safety, Applied Informatics and Automation and Mechatronics, Advanced Technologies Research Institutes, and as far as other workplaces and research areas, we have at the faculty established Center of Excellence for 5-axis machining, also Center of Excellence for Diagnostic Methods, as well as University Scientific Park Botova campus with acronym CAMBO. Next one, please. As I already mentioned, in our project, we are dealing with linking research and innovation, and the way also how to implement actively innovation is our strong collaboration with European Alliance for Innovation. We have also established close to our university European Alliance for Innovation in 2013, for what I'm really proud of it, as we established this with two aims. One of them is actively contribute to organizing scientific summits and conferences to collaborate, to deepen mutual collaboration among universities, not only at home, but also all over the world. And also the second main issue is to support creation of international consortia who can actively be involved in solving particular project topics. Next one, please. And also, I would like to focus that within European Alliance for Innovation, there is just trend from research to innovation, from the point of view research to enable to publish, to present person and also participant in various scientific events, also to involve community who is dealing with particular topic, also with aim to evaluate the project and provide professional feedback, and leading to innovation. And what is really important is important networking, and also via offering partnership and different sources of financing, and also with possibility to push the ideas to get to the market. Next one, please. As far as international collaboration, I have to say that, as you can see, we have very deep and strong collaboration, and I sincerely appreciate this networking and partners who are actively collaborating in various areas. And I have to say that also we are satisfied that we were successful together with Ukrainian University in Erasmus Plus ICT. So I believe that this will be also the way how to be involved in various project solution more actively. Next one, please. And one of the ways how to support linking research and innovation are summits and conferences. And as I already mentioned, as you can see, I can declare that we have also very serious collaboration with Associate Professor Vitaly Ivanov. You can see also Dr. Ivan Pavlenko, as well as Dean Oleg Zabolotny, where we collaborate on conferences. And also there you can see that I would like to also invite you for deepening this collaboration also through conferences. Next one, please. Also, which we organize in virtual cyberspace this year. We focus on mobility and IoT. And I think that there are topics who are really close to your expertise, as one of the areas is technology innovation, with focus on Internet of Things, everything, or Industry 4.0, with focus on innovation and management and smart services, new business models towards urban mobility, automotive industry, smart city structures, transport system, through social mobility, and leading to sustainability towards environment and climate resilience future. Next one, please. And at this moment, I would like to share with you our project H2020 with acronym CALIPER. We started to be actively involved in solving this project from 1st January 2020, which is lasting 4 years till the 31st December 2023, and it is in agreement with 5th Sustainable Goal of Agenda 2020. And as far as project aims, one of the project aims is to support research institutions with focus on STEM. It means science, technology, engineering, mathematics, in designing and implementing gender equality plans. And also our aim is to ensure sustainability and expansion of these plans in both levels, international and national, and also try to implement these innovative strategies and also create strong linkage between academic, governmental, industrial, and organizations which are in the area of civil society. So I would like to summarize that CALIPER's mission is to design, develop, and implement sustainable gender equality measures. Next one, please. As far as from aims, I can say that at this moment, just recently, we have submitted the first report where we were finalizing internal and external evaluations. And also within these 6 goals, we are trying to ensure an effective and adjustment implementation of these gender equality plans, and also try to take care of transfer of knowledge within these institutions. Next one, please. Our project consortium consists of 7 research performing organizations, especially universities, like University of Brussels in Belgium, or University in Turkey, in Barcelona, Institute for Research in Biomedicine, National Technical University of Athens, Greece, and many others. Also 2 research funding organizations, partners are from Georgia and Romania, as well as charity organization, Young Academy of Europe from Germany, and SMEs, partners from Smart Venice, Italy, and also coordinator Billups from Greece. Next one, please. In this slide, you can see detailedly described activities within work package number 5. For this work package number 5 is responsible our institution, our university, and the aim is to develop the project dissemination strategy and also implement these makers, and also try to support researchers to raise their policy activities, and also will study to different stakeholders, such as research performing organizations and research funding organizations. Next one, please. So I would like to introduce you the results we have obtained just recently within these 6 months from the beginning of the year, and they are connected to internal findings. So just some statistics for your overview that female senior lecturers are approximately 55% for last 5 years. And as far as female professors at our faculty, I have to say that it is since 2019 just 1 female professor. So really we have to say that we have only 1 female professor at our university. And that's why we are trying to find a solution how to support it within not only faculty but also within universities. But as far as remuneration of males as females at our faculty, we have to say that there is no distinction. But what is positive, that female are in leadership positions within our faculty is 44.44%, as they are head of department, unit, and faculty management, what we consider as really positive trend. Next one, please. And as far as number of students, for example, successfully enrolled and graduated female students in year 2019, where you can see in statistics that for bachelor study it was enrolled 158 and graduated 60. In master study enrolled 116 and graduated 107. For PhD it was 4 and graduated 7. So you can see that we have really deep and strong demands for our students, so they have to be prepared really very carefully. And also I have to say that the way how to try to avoid gender bias is also double-blind review process to assess the expertise of articles before publication in a journal. Next one, please. As far as internal findings from teachers and professors at our faculty, I have to say that they are aware of gender bias in teaching. And also, I have to say that gender-based stereotypes affect recruitment to certain job positions. And we think that according to the expertise of various universities and partners, that the language used, for example, for job advertisement and websites is subtly filtering men and women, and so we need to implement and improve more gender-sensitive language. But as far as job interview, I have to say that we have no gender discrimination. Next one, please. Also, we were verifying also awareness of complaint mechanism and also promoting various awareness-raising campaigns and how to fight with stereotypes. And I have to say that only certain percentage is persuaded that it is definitely or relatively very low that there is promoted awareness. So our conclusion is that we have to be more and more dealing with this issue. Next, please. As far as external findings, we have to say it's very important. If something we want to work, it is necessary connection to legislation. And we have to say that we have no legislation support on national level. So it is necessary to promote underrepresented gender in scientific research and innovation at both levels, national and regional. And there are targets for increasing the number of women in the area, and it is possible to do it while national strategy for gender equality in the Slovak Republic, which was for year 2014-19, and also supporting via action plan for gender equality in the Slovak Republic, which was for the same 5 years. And as far as innovative enterprises and startups in Slovakia by gender in 2016, we can declare that there are 3/4 of male, about 76%, and 1/4 of female. So we were trying to verify how to support it, how to develop it, and the responses were like financing the startups, would mean that women entrepreneurs would welcome more assistance with various areas expert advice regarding the initial business stages, like especially financing, planning, business plan elaboration, and also support with the process of direct application. Next one, please. Another highlights from external findings are that external subjects are interested in continuing to collaborate with our faculty in the future to be able to overcome such inequalities. And they see the way maybe via exchange of knowledge in the field, or also very good useful way is collaboration in the projects. And this also what is interesting finding, that really such result and such conclusion can be that it can be influencing atmosphere in the workplace, corporate culture, communication, and management work. Next one, please. And as far as focus group results, it is really useful that benefits that an innovative approach for gender equality can bring to society are clear rules in the workplace, employee satisfaction, what we really want to make our employees to be happy and satisfied, and that's why they can be more innovative and more intensively involved in research. And it also improves better atmosphere in the workplace. So we think that this training would be really appropriate to raise awareness of gender equality. So I believe that there will be chance to continue in these activities. And I see that also our members of the project consortium, as well as our internal members, are more and more deeply with this. And I am also thankful to all our partners, internal and external, for their active contribution and for support from various areas. And I would like to, at this moment, ask my colleague, Associate Professor Ladislav Morovic, to continue with presenting our second H2020 project with acronym DECOMI and with title Directional Composites Through Manufacturing Innovation. Latko, please, it's your turn. Thank you very much.
Thank you very much. Ladies and gentlemen, please let me to introduce very shortly about the Horizon 2020 project. As Associate Professor Dagmar Caganova mentioned, the acronym of the project is DECOMI, what is stands for directional composites through manufacturing innovation. The next slide, please. The next slide, please. Please, the next slide, because I think it's not the correct slide now. Yes, it's okay. So this Horizon 2020 project is financed by the European Commission, and this project is mainly for the mobility project. So in the projects we are involved 17 partners, mainly from Europe, but also from the world. For example, the leader of this project is the Loughborough University under the leadership of Professor Ian Campbell. But for example, from Romania, the Technical University of Cluj-Napoca is involved in the project with the under the leadership of Professor Balk. Also, from Ukraine is the National Aerospace University. The Department of Composite Structures and Aviation Materials is in the project. Also, the Aachen University. So many companies and universities, but also from New Zealand, South Africa. So the aim of the project is to bring together the leader innovators from across Europe and the world, and to develop a new method of producing composite materials part with optimized fiber directionality. What it means? It means that we would like to manufacture with a new, relatively new hybrid manufacturing technologies, 8 parts, polymer material parts, which are reinforced with carbon fibers. And these carbon fibers are directed, and with this directed manufacturing of the parts, we can make a better or stronger the parts and lighter the parts. These parts will be available mainly for the automotive industry and for the aerospace industry. As we can see on the slide, yes, this project consists of 5 main stages or 5 main working packages. The performance specifications, where we would define that what we want to do, how we can to do. Also the study about the composite materials. It's very important to choose which kind of materials will be used. I will talk about a bit later. Also, it's necessary to design the hybrid manufacturing systems. Also, I will talk about it very shortly, a bit later. And after, it's very important to test the hybrid manufacturing systems and make material testing of the manufactured parts. The next slide, please. Yes, the technical solution of the project is based on 3 pillars, as we can see on the slide. These are the advanced manufacturing techniques, the composite materials, and the hybrid manufacturing systems. On the next slide, I would like to say a few thoughts on these main pillars. Please, the next slide. The next slide is about the advanced manufacturing techniques. The main philosophy of this hybrid manufacturing technique is combine the advanced manufacturing technique and the subtractive manufacturing method. Why it is important in this case? It's important because with the help of additive manufacturing technology, we are able to manufacture very complex geometry. We would like to use the additive manufacturing method to use deposition modeling, which is now a well-known technology, a relatively low-cost technology. And this technology is able to manufacturing the part layer by layer of vertical layers, but we would like to combine with using a multi-axis printing head to not manufacturing just the vertical layers, but also the curved layers, as is on the picture below, on the figure below. But the problem is that the 3D printing from the aspect of mechanical engineering is not enough accurate. So therefore, our aim is to use the milling technology. With the help of milling technology, we can manufacturing accurate surfaces, not all the surfaces on the parts, but just the important surfaces, which will have a role in the life of the part, for example. The next slide, please. Yes, so the composite materials. During the study of the composite materials, we are find some interesting materials which are usable for this technology. We would like to use the fuse deposition modeling technique. It's mean with the extrusion of the material, plastic material, which will reinforce it with the carbon fibers material. The matrix polymer, here are three alternatives: the polyamide material, or the acrylonitrile butadiene styrene material, or the polyether ether ketone material. These are very known and tested materials, so I think it will no problem to use these materials on the manufacturing processes. But what is still a new technology, and it is one of our aim focus for the testing this material. What will be happened if we will combine this material, polyamide, acrylonitrile ABS material with the carbon fibers, and how will influence the direction of the carbon fibers for the mechanical properties of the material. The next slide, please. Now I would like to tell something about the hybrid manufacturing systems. As I told you, it will the combination of a additive manufacturing and a subtractive manufacturing method. It's also under the testing that which type of kinematic structure we will use, which axis will do the rotational and which the translational movings. It's under testing, so in this phase I cannot speak about more or talk about it more. But also we are thinking about the using of robotic arm, because it's also a possibility to manufacture very complex surfaces. The next slide, please. In the next slide, I would like to summarize this things what I told until this moment. So our aim is to manufacture a hybrid system, minimum for 200 times 200 times 200 millimeters. It will the manufacturing volume or the building volume. We would like to use a polymer material to be fed into the system in the form of filament. The diameter of the filament is 1.75 millimeter. And as I told, it will the combination of the 3D printing and the milling technology. Our aim is also to develop a method when we will use just the minimum volume of the support material, because the support material is just for supporting the structure, so it will be very economical to save the material by the way of not to use too much support material. The extruder head working temperature will approximately 460 Celsius degree, and of course the dust extraction is required during milling operations. The input files will the STL or OBG files, and what is very important is this is a low-cost project, so the output from the DICOMI project will be a low-cost hybrid manufacturing systems. In this case, it's mean plus minus the cost for the hybrid manufacturing system is about 10,000 euros. These are our aims. We are working now with. In the moment, we working on the design of the manufacturing systems. It means we are working and testing the kinematic systems. We will have still 2 years to ending this project. So now we are approximately at the middle of the solving of this project period. So thank you very much for your attention. And now I would like to give back the word for Associate Professor Dagmar Caganyova.
Okay, thank you, Ladislav. Dear ladies and gentlemen, next slide, please. I would like just finally declare that this presentation was prepared on the basis of our active involvement within these two European H2020 projects with acronym CALIPER and DICOMI. And I think that also this can be some starting point to enrich our collaboration, maybe in similar projects. And I think that we can find really various areas where we can collaborate in the future. And I believe that also this Erasmus Plus successful project can be one of the tools where to start more intensively to collaborate. And I hope that after coronavirus COVID-19 will be under the control or come to the end, there will be much more opportunities for mutual exchange of scientific, pedagogic mobility, as well as mobility of students, and to have a chance to work on particular activities. Next one, please. And finally, once more, let me express sincere thank you very much for inviting us, for having this opportunity to share our experience with this project. And also, I believe that this is the impulse for further collaboration. And I sincerely hope that in the next or the following years, we will have an opportunity to meet personally, to have a chance to see a wonderful social program which you always prepare to share your unique culture. And I believe that we will have again many other opportunities to collaborate in various ways. So let me wish you good luck to your conference and very good, friendly support to you, atmosphere for all presenters, and also all the best to our following speaker, Associate Professor Milan Edl from Plzeň, to continue in this conference. Once more, thank you very much for your kind invitation.
Thank you very much for your interesting speech. Dagmar, Vladislav, thank you. Maybe some questions from YouTube? Chat questions? No? No questions? Oh, okay. Vladislav, Dagmar, I will be glad to see you in Odessa in 2021. Thank you, and bye.
Thank you very much.
Thank you very much.
Thank you. Next, our speaker is Milan Edl from West Bohemia University, Plzeň, Czechia. Is Milan now? I don't see. Milan? Oh, I see you. Hello, Milan. Milan Edl is a dean of the Faculty of Mechanical Engineering in the University of West Bohemia. He focused on the development of advanced industrial engineering concepts, the implementation of industrial engineering methods as a tool for the competitiveness of enterprises, the sustainability of advanced production systems with high added value. Other areas of expertise include the application of mathematical and economic approaches to problem solving and applied informatics. Today, his speech is ecosystem as a tool for the development of the region, the Pilsen type ecosystem. Please, Milan, you can start.
Дорогие друзья, hello, hello. Do you hear me?
We listen to you.
Okay. Let me. Okay. Thank you. Thank you for inviting for us keynote speaker for this conference. I am very happy that we can meet in this virtual way, but face-to-face meeting is better for us, I think. Okay, my contribution has name ecosystem as a tool for development of the region, the present type ecosystem. Okay, just a moment. Please. I don't see right slide. Yeah. Firstly, I would like to define the ecosystem because ecosystem has many definitions. One definition is defined by Arthur Tensley. This is English botanist and pioneer of the science ecology, and one of the key concepts of ecology first defined by Mr. Tensley in 1935 as a set of organism and factor of their environment in the unity of any hierarchical level. Next slide, please. On this slide is maybe two ways. A definition for our purposes is better. Second part, this is a combination of real life, real and unreal components that collaborate between us. Next slide, please. This is cooperation between ecology, economy, culture, and regulation. Next slide, please. On the next slide is better description. This is combination. Firstly, industrial companies, cooperation with policymaker, governments, local authorities, local governments. Next is education research, laboratory, universities, middle school, high school, founders, insurance, investors. Next is third sector. This is, for example, various association, business chamber, and so on. Healthcare and social care, for example, hospital professionals, and so on. Next slide, please. This is our region. Many from do you know city Pilsen? This is region on west, on right part is west part of the Czech Republic. This is Pilsen region, Karlsbad region, South Bohemia region. And left side, this is Bavaria, part of Germany, and this is Oberfranken, Oberpfalz, and Niedermayr. This region is very close and very close cooperate between universities, between research institute, between hospitals, between tourism, and so on and so on. Next slide, please. This is description, very briefly, this description of Pilsen region. Pilsen region is mainly orientated to industry, to production of alcoholic beverages, ceramic production, energy, and so on. Next slide, please. South Bohemia region is orientated to industry, to agriculture, and so on and so on. Next slide, please. Karlsbad region is oriented mainly to spa industry, but in this region is many industrial companies. Next slide, please. This is region is Oberpfalz. Oberpfalz is maybe very close cooperate with Pilsen region. It is orientated to agriculture, forestry, fisheries, orientated to university education, and so on. Next slide, please. Niederbayern, this is south part of our cooperation region. This is orientated mainly for industry company, for example, BMW, agriculture, and so on. And last region, next slide, please. Oberfranken. This is second highest industrial density in Europe. Very strong industrial region. This is a good potential for cooperation with us. Next slide, please. Various opportunities for this wider region. I say this is a region without border. I think a very strong topic is industry. Next is education, nature, health. Concrete is universities on both sides. Many high school on both sides of border. Basic school. Small enterprises, industrial research institutes, cities, villages. We realize many projects cross-border orientated to sharing industrial research equipment, service, tourism, trade, agriculture, new business model, and so on and so on. In this region is very big potential for cooperation. Next slide. What about us? I try explain several words more philosophical, for more generally. We must fight more uncenteredness. We must fight more changes, less work and social security, more people in need of help, exhaust nature, major geopolitical, demographical value changes, maybe health changes, and transforming of the world. Next slide, please. And very necessary is what are the changes around us. I think in this time is time for big productivity growth, higher profit, and fewer jobs, because very strong aspect for today's is digitalization and rationalization. From my point of view, young people are most affected. They have not a job. They have, but I think they have dreams, for example, vision, and so on. And older people is their count is growing. Next slide, please. What do we have to prepare for? We must prepare for our understanding yourself, understanding your surrounding around us, maybe generally understanding of the world. We must prepare for decentralization, for example, as a family, community, independence from central institution. We must prepare for cooperation and mutual assistance, networking, cooperation, business, new business model, change of thinking. And everyone will be entrepreneur. We must make business with own talent, own life, and so on. Next slide, please. One sentence from famous Czech businessman Tomáš Baťa. I think that do you know who is Tomáš Baťa? Tomáš Baťa say the most important production factor is brain. The company needs talent and their knowledge. The factory is just a pile of brick and iron. People give her life. I think this is very important sentence because the most important in every, not only company, but in university and society is people. People has many roles, and people is basic, maybe I don't say capital, but basic capital for development, not only region, but all society. Next slide, please. What is necessary? I think in this time is necessary shortening on timing of product to launch time. Very necessary is product quality orientation, modularity of the product, cost reduction, maybe optimization, flexibility, teamwork, learning, knowledge of human, and so on and so on. Next slide, please. This slide describes main goals for today's. I think in this time it must be innovative products, new business models, development and of production strategies, emerging technologies, infrastructure, and last but not least is education for all. Next slide, please. Customer roles. Customer roles during last century is very changed. Customer can be customer for some product, some industrial product, but customer for education, for example. This is maybe our students. On the 60s, we can speak about design behind the customer. In 70s, we speak about the design for the customer. In 80s, we can speak about design with customer, and today's is designed by customer. Role customer is stronger and stronger, and this customer say what exact do you want final product. Slide, please. Today's necessity is networking, modularity, integration, digitalization, rationalization, and work with people, socialization. This is basic components for successful product, not only physical product, but product plus service plus cooperation in every region. Next slide, please. Cyber physical system. This is a very known term or definition. I say very often about social cyber physical system. This system of operation, virtual model, information technology, controlling physical entities, physical of the production system and technical environment with respect and man as a worker. Next slide, please. cyber, physical, social. This is three basic components all today's systems. Next slide, please. Why is it necessary to change anything about contemporary education in this time? We live in time where fundamental changes are taking place, not only in industry and the economy, but in principle throughout social general. Not only industry, not only education, but general economy, general society. And we can talk about transforming society as a whole, about changing paradigm that seems unshakely. All is other, from my point of view. Next slide, please. This is change of thinking, change of mindset. This is my favorite picture that describe deer on the road. Things are often different than they seems. The deer not going over the road, but road go through the woods. This is another point of view to various situation in today's situation. Next slide, please. For reflection, we speak about revolution or evolution. I think by technological point of view, this is evolution. This is continue changes. But in thinking, we speak about revolution. This is my point of view for this situation. Next slide, please. This is a change of paradigm. For example, some business model. Very interesting is business model Facebook, Uber, Airbnb, for example. Airbnb is the biggest not owner, realizator of accommodation in the world, but this Airbnb is not owner of this rooms, this flat, this hotels. Uber, it's same situation. This is the biggest realizator moving taxi service, but Uber have not one car. Haven't car. This is change thinking and the new business model. And how can be situation, for example, in the university, in education? Can be in future exist some virtual university with no professor, with no assistant, with no study plan? I don't know. This is a change of paradigm, and this is very necessary point for thinking for the future. Next slide, please. National initiative Industry 4.0. That is not only Czech Republic and all Europe and all world, consistent or focused on new requirements for applied research, new standardization requirements, new safety, reliability, availability, and requirements, impact to labor market, scaled labor and social impact, and impact to the educational system and necessary to the legal framework. We must orientate it for all. Next slide, please. Very briefly, I would like to say several words focused on labor market and education system. Next slide, please. On labor market, from my point of view, very important. This is change on today's labor market. The change principle of work organization, changing a role of employee, change of job description, setting labor market policy and education, digitalization of work or virtualization of work. This impact on labor market in today's. Next slide, please. Another changes in labor market is decentralization, work for more employer, flatter organization structure and amorphous structure, and many professions demise, and many profession create as a new profession. Next slide, please. What is situation in educational system? Consolidating the role of specialists, but also prepare new interdisciplinary tutorials and study program at a horizontal integration of knowledge and experience from different disciplines, and securing system perspective, and using new technologies to move from teaching new technologies to interdisciplinary system approach. We prepare a study program in English language that is orientated for implementation this. Next slide, please. This is example for new professional. For example, director of digitalization, model-based system engineer, digital manufacturing technician, data flow engineer, cyber security strategist, engineer for build product forecaster, virtual reality, augmented reality specialist, from an ethic for digitalization, specialist for collaborative robot, user-friendliest developer, digitalization and automatization engineer, change management strategies, supply chain management, and so on and so on and so on. This is a definition of new professions that we must prepare students from our universities. Next slide, please. What to focus on? We must focus on education, talent search, raising the knowledge level, learning, research, cooperation between industrial practice, and so on and so on. Next slide, please. This is a description ecosystems. This ecosystems is cooperation, research organization, preparation new startup, cooperation with small and middle enterprises, large companies, industrial association, investors, governments, incubators, and so on and so on and so on. Next slide, please. We must focus on cooperation in basic triangle. This triangle is industry, university, students. Industry and university must cooperate with strong connection between industry with universities. Understanding needs of industry. This is the role of university. Working on a real problem is very necessary for quality of future employee. Participation on participation of industry in teaching and in project. Defining necessary research topic for research institute on university. Support for activities and supporting graduates. Next slide, please. Role between university and students is learning of theoretical, maybe practical basis, development of students' knowledge and skills, raising the knowledge level of students. And next slide, please. And relation between student and industry is identification of needs for defining a future excellent engineer, involvement of students in problem solving in industrial enterprises, building for foundation for future potential employee, and thinking in dimension of industrial enterprises. And this is a model is very necessary for preparation new employee, for future employee students for industry, to practice generally. Next slide, please. This slide describes concrete steps for successful cooperation in region. From my point of view, long-term cooperation with industrial practice. This is very hard work and very long work. Establish a strategic partnership model with industrial practice. Effectively functions industrial council, employers council, and so on, as a feedback to industry, to university. Integration, research and development staff to the teaching. Closer cooperation with faculties with social base. Modular education system of future education for educators at university. Training system for industrial workers, cooperation with foreigner universities, and internal quality management system. I think this is very necessary for successful position in every regions. Next slide, please. Lacking courage, maybe. We have a huge investment in science and research. We have huge investments to universities. We have support of production technologies, but I think often it's missing courage to go for it. I think this is a basic problem for maybe young people, not only young people. Next slide, please. How to do it? I think this is combination technology, challenge and opportunities, and healthy common sense for solving problem. Next slide. Maybe one philosophical slide. How to do this? I think the basic is culture, corporate culture. Then is value for all. Then third is innovation, ability to change, and I think working with people. This is never-ending process. Next slide, please. Never-ending process means continuous improvement and respect to people. This is very simple, but very hard work for successful working. Next slide, please. Maybe various problem limits of technological saturation. We have many technological maybe devices. We have able to work with technology. We have able to advance to technology result, but we must basic problem is working with people. Next slide, please. This picture is from internet. Very simple. We don't have Wi-Fi. Talk to each other. I think people must communicate face to face more. Next slide, please. This is last picture. Success. describe success. Sorry. And last slide, conclusion. This is sentence from Professor Zelený from the Czech Republic. The main goal is to produce people who can do new things, not just repeat what previous generation have created. We need people creative, resourceful, and discover the purpose of education is at value. Thank you very much for time and for attention, and many greetings to Odessa and last other cyberspace.
Thank you very much. Thank you, Milan. Maybe some questions from YouTube, the chat. No questions? No. Thank you, Milan, and I will be glad to see you in Odessa maybe next year after pandemic. And bye.
Vladimir, thank you very much for control this section, and I am happy that I see you and other colleagues, and many health to you, and I hope that we meet face to face.
Oh, thank you, Milan.
До свидания.
До свидания. And our first session, Keynote session, is over. And I would like to introduce next our session, Chair Professor Vadim Stupnitsky from National University Lviv Polytechnica. Vadim?
I'm here.
Oh, I would like to give him the chair.
I can begin, yes. Dear friends, I am very glad therefore we have some problems with connection. Our reporter for this conference, because the schedule of our conference will be was changed. Therefore, we have continue our session, Keynote session, in 11.35. Yes, isn't it? Yes. Yes, this keynote session will be dedicated to the problems of mechanical engineering, especially for use conception of Industry 4.0. It will be 2 reports in this session, and it will be very interesting, because really interesting and important problems, not only for Ukraine but for all countries in industry. And therefore we have a short break, and after this we'll connect to the conference. That's all.
Yes, хорошо. Да, конечно. Конечно. Привет. Да. Я уже готов.
Да-да, я слышу. Я подготовил пару вопросов к словомеру. Может быть, я
Да.
ему передам сейчас, чтобы он знал, что я имею в виду, и какие вопросы, чтобы оно было немножко так, ну, то есть какие-то вопросы
condition for assisted.
Not very correct. This process from theme, the subject of your report. Yes.
Pardon?
I said that maybe. And you're talking about automated assembly production, yes?
Yeah.
Yes,
Oh,
but however,
no full automated
not,
assembly process. It is combination of manually automated assembly process.
but implementation and flexible multi-products production for serial assembly is very, very difficult. Yes.
Yeah, it's very.
Yes, and the complex intelligent decisions.
Sorry. I have to switch off YouTube because I have a problem. Yes, because I heard you twice. Yes, 30 seconds late.
There are.
I have to
just a moment. There are.
Use only Skype chat.
I closed.
Sorry, I have to find it.
And about, you said that maybe this conception can be used not only for or fully automated assembly production. This conception can be used not only for full automated assembly production. Yeah.
Sorry, I have to switch off YouTube and I can't find it.
Yes, yeah, it's right.
Вадим Владимирович, давайте начинать секцию уже 11:35 по часам студии. Okay. Давайте перенесем все эти вопросы в дискуссию, это будет очень красиво.
Dear friends, yes, I can begin. Yes. Dear friends, I am very glad that we have enjoyed for this conference despite the great problems. We remember how interesting and important the previous conference in Odessa was a year ago. And I hope that our connection, our conference will be very many times in Odessa next year, after next year, and after this. We are opening the new keynote session of our conference. I said about this earlier that it will be dedicated to the problems of mechanical engineering. First of all, from view of using conception industry 4.0. Sorry. As our chairman said, I'm a chair of this session. My name is Vadim Stupnitsky. I'm a professor of Department of Mechanical Engineering Department, Lviv Polytechnic National University. We are starting the communication. The first report of keynote session is research of digitalization of assembly process for Industry 4.0 concept. Keynote speaker is Jan Pitel from the Technical University of Košice, Slovak Republic. The time for report about a half hour, not more, I hope. And let me remind that everybody have to make the notice in your question, put your question in YouTube. And I try to avoid this question to the reporter. Please start your report.
Unfortunately, good morning and welcome to all of the participants. I am not Jan Pitel. I am Sławomir Luściński.
Sorry, but
you should switch to Jan.
Sorry for
Jan,
our
I was a demo version for you.
Sorry.
For our.
I hope you are satisfied.
Sorry. For our child.
Jan, you should switch to Jan.
For our child,
yes.
it was Jan fast. Sorry. Please start.
Please start presentation. Yes, but I don't see my presentation. Yeah, it is a middle screen, yeah?
Middle screen, yes.
Yeah, middle screen, okay. Okay. So, good morning. Thank you very much for introduction. As the chairman said, I am from Technical University of Košice, and my presentation will be about our research on digitalization of assembly process for Industry 4.0 concept. The presentation was prepared with my colleague, Associated Professor Kamil Židek. Something about our university. We are the third biggest university in Slovakia, located in Košice. It is the east part of Slovakia. The university has 9 faculties, consists of 9 faculties, and 8 faculties are in town Košice, and 1 faculty, our Faculty of Manufacturing Technologies, is located in town Prešov. It is about only 40 kilometers between Košice and Prešov. The faculty was raised, I think, in 1992, and now we have about 1,000 students and about 70 researchers. Next slide, please. So, something about motivation. What is our motivation to do such research? I work at Department of Industrial Engineering and Informatics, and this department is a leader at Faculty of Manufacturing Technologies for implementation of Industry 4.0 principles into faculty education, of course, research activities, and also with collaboration with practice. The main motivation, of course, implementation of Industry 4.0 principles into manufacturing. As you probably know, the Industry 4.0 was introduced in Germany in 2011, but some principles of Industry 4.0 are used before this introduction. Of course, I work in the field of automation, and with some technologies used in Industry 4.0, we used them also before this introduction. What is very important for our work, for our research on this in this field, we have three international projects about this. One project, H2020. It is focused on smart manufacturing and logistic for SMEs. The project leader is from Free University of Bolzano. Another project we have UREC. It is a project not strongly oriented on the manufacturing, but some principles of identification we used in this project. And the third project, what is close to Industry 4.0, is Erasmus Plus strategic partnerships, and we have project to improve the doctoral education on Industry 4.0. It is also supported by national project. We have 3 basic projects at our department. One project from basic research. It is an abbreviation of Slovak agency, grant agency, VAGA. It is a project oriented, focused to identification of product defects using advanced object recognition techniques. We use convolutional neural networks. Another project is applied research. It is supported by another our great agency. At this project is focused on designing of modular multifunctional inspection workplace using computational intelligent techniques. We use the knowledge obtained from the basic research project, and we use neural networks. And the third project is educational project, and it is focused on transfer knowledges from our research to educational program process at our faculty. Next slide. So, what is the aim of research and main research task of our research? As you know, we now live in the digital world, and digitalization is very important also in manufacturing and especially in assembly process. This digitalization is conditioned for quality control operation. It is one important part of digitalization, and also it is very important for assisted assembly implementation because when we want to assemble not simple products, it is very useful to use assisted assembly based on virtual reality or augmented reality. About quality control, everybody knows that it is very, very important part of manufacturing. In assembly, the aim is to prevent components faults and to identify any defects after the components have been assembled. So it is important before assembling process and also after assembly process. So something about digitalization. Of assembly process is very important to use new approaches to how data is captured. It is very important, stored, analyzed, and used. This is four basic parts of digitalization of general manufacturing process, of course, and especially assembly process. So we have to use suitable technologies for fast digitalization, data transfer, data storage, and finally data mining have to be used. So maybe I think that company Siemens the first used the term of digital twin. Digital twin is a virtual model of a real process, and so our aim, our research goal is to create digital twins of inspection and identification system and personalized digital twins for every assembled products and its parts which are used in assembly process. Next slide, please. Something about the research methodology. We try to use, of course, principles of Industry 4.0 concept in data acquisition from manufacturing environment. The first task for data acquisition in data collection from production machines, production process, and products. This is the main three parts of manufacturing, which has to be covered by data collection. Data from a production process can be provided by integrated position check sensors. It was used before Industry 4.0, special sensors, for example, optical sensor, laser sensors, this is new sensors, or classical inductive proximity sensors. These sensors, as I said, are often used in control and monitoring of manufacturing process, and it is a classical approach. The next task is implementation of technology for exact part localization in production. Because the sensors which I introduced in previous, they are not able to exact part localizate in production. So there is very useful technology of RFID technology, which can provide information about product, about status of product, and so on. So the typical parts of RFID technology are the reader with RFID transfer, and of course there is need to use some RFID labels on the final assembly or parts which are included into assembly. Next slide, please. So, very important part of digitalization of assembly process is using of vision system. We use user system in our department maybe 10 years. We have been using this system, and we have some experiences with standard part identification, part presence check-in, dimension check-in, definite tolerance, and also now in the last times also assembly check for product completeness. Something was said in the previous, can you speak about product life management? And it is very important to have information about the product during its life. And so there is need for automatic feedback from realized products. The solution is used MEM sensors with combination with IoT devices. Now, then when data are acquired, it is very important part of digitalization is data storage and knowledge representation. The standard databases cannot be used because the amount of data from digitalization of manufacturing process is very high. So special system has to be used which can use big data technologies, for example, cloud computing and so on. The one possible solution is used now. We're working with time series databases. It is very useful solution for storage and then visualization of data for manufacturing process, and because they are very useful for collection data from IoT devices. Next slide. What about something what we did in this field? So for these purposes, as I said in introduction and then in research methodology, we designed experimental manufacturing assembly system, which was designed to follow the principles of Industry 4.0. Next slide, I will show the principle of this experimental manufacturing assembly system. Now I can say the basic parts of this system. The basis of this system is conveyor belt with PLC control system, and servo motor to be able fluently change conveyor speed depending on production process status. For identification, they applied RUD technology, vision system, and IoT devices for the digital data acquisition. The problem is that these different technologies have a different output and so on and so on. That's why the data must be transformed to standardized industrial format. For this purpose, we used the special OPC server written in our department. The basic collector for data is a PLC system because this experimental manufacturing assembly system is controlled by PLC. This PLC system is used for data collection and processing them to transfer to cloud system. About OPC server, I said something. This OPC server was written in Python by our PhD student, and it provides data distribution to digital twin based on Siemens Technomatics Plant Simulator and the cloud platform MindSuite. Last 5 years, maybe our department we are oriented to use Siemens technology. Why? Because many production machines in our companies have a Siemens control system. That's why it's very important to have all chain Siemens. So 5 years ago or 6 years ago, we have started to teach our students Siemens Technomatics Plant Simulator. That is very important to them for prepare the diploma work in companies where used the Siemens technology. What is the point of interest of assembly? It is about the whole assembly from 3D printer, where is the main part is tipper motor. There are some plastic components and some fastener parts. I will show it in the next slides. Next slide, please. So this is the block diagram of experimental manufacturing assembly system. There are numbers, so I try to explain it using the number. Number one is RFID system. There are two main RFID systems. I will show them in the next slide. The basis is conveyor belt. This is in red and green color. The green color serves for parts, and red color serves for assembly. Very important part of this system are vision systems. There are 4 vision systems under number 2. I will explain them. So the number 3 is this fourth vision system because it is a system for part identification by neural networks, and this is a special system. So number 4, PLC and SCADA. We use, as I said, we use PLC system Siemens and SCADA of this company 2. 5, OPC server written in Python. It is a special OPC server for transfer data between PLC, digital twins, and cloud. 6 is a digital twin. As I said, it was designed in Technomatics Plant Simulator. 7, cloud platform. We use MindSphere. It's a Siemens cloud platform for big data processing. 8, IoT monitoring cloud. We also use some IoT sensors which information are stored in special IoT monitoring cloud, which is running in our department. 9, this is an educational robot for assembly process. We start with it and some results I will show maybe in the next conferences. And 10 is store of input parts and also output of final assembly with IoT. Next slide. So this is a real picture from these experimental assembly systems. The numbers are according to the block diagram. As I said that point of interest is a Bowden holder assembly from 3D printer. It can be seen on the right side of this slide. There we can see different models of this assembly. Next slide, please. Something about RFD paradigm detection system. As I said, it consists of two basic parts. Two basic gateways. One gateway serves for assembly identification, and the second serves for calculation, but technology, but use technology of Siemens. Next slides. Here we can see the parts with RFD tags. There are three types of RFD tags. The first one is black color in the left side. It is on the picture. Yes, it is the biggest size. The second RFD tag is on the plastic part of red color, and the third is on. It is not so good to see. It is on the white plastic part of assembly. On the right side of this slide, we can see the typical data captured from RFD technology. It is a picture from SCADA system of PLC, and there are some information about the RFD read by RFD system. Next slide, please. Vision system. As I said, we use three of four can be said vision system. As I said, also we work with vision system. Maybe we have been working maybe for 10 years, and so we have some experiences with the different technologies and different using of vision system. The first one was used for surface inspection. It was based on 5 megapixel camera Omron. This technology we bought, I think, 5 years ago. The second vision system was used for dimension check. Very interesting system, because this system is very often used in companies. And we have a good collaboration in practice in this field, and we use Cognes system. The third system was SIG Inspector. It is the last system which we bought, and its system serves for checking of assembly completeness. And the fourth system is a special system. NVIDIA. It is a system for part identification. We use them for identification using convolutional neural network. It is a special system because the previous three systems are industrial system with a possibility to change the algorithm, and the last system is system which allow to change algorithm, and it is very interesting system for research. Next slide. Here we can see the system. Left Omron, Cognex, SIG Inspector, and NVIDIA. Some results from this system. Next slides. So, surface inspection by Omron. We can see result in yellow square is you can see some problem on the surface. The B dimension measuring, it serves for checking of dimension of parts which are entering to the assembly process. The C is results of assembly completeness checking. Is very important because the worker can do something bad, and it is a system which finally checks the completeness of assembly process. And the D is the results of the new system which serves for part recognition. Well, it is not easy to recognize the small parts, for example, screws, washes, and so on, nuts, as we can see on this slide, and it is a result of recognition 90% and result of recognition. Next slide, please. Something about digital twin. As I said, for the first time, I have heard from Siemens company. Digital twins is a digital copy of real process. So we can say that it is a digital replica of virtual model for several hierarchical levels. It can be digital twin of sensors, can be digital twin of production unit and plant, of course. So when if we want to create digital twin, we have to treat 3D models of individual parts, and very important is to have a good possibility of remote monitoring and data synchronization with real system and offline simulation. So it is not so easy, of course, in some cases. So that's why, as I said, we designed the OPC EC server written in Python, which is connection between PLC control system of Siemens and Technomatics plant simulator. We use technology Siemens in process level and also on monitoring level, but there were some problems which were served by this OPC server. And as I said, the main collector for data from inspection or identification system is PLC. So on the block diagram on the bottom of the slide, we can see the bidirectional data synchronization between used technologies. Next slide. So this is a real pictures of 3D models created for digital twins. On the left side, we can see the 3D models of the fixture with parts, and on B picture is a 3D model of the assembly, and C picture is a 3D model of the belt conveyor with equipment used for the identification purposes. Next slide. Here we can see the 3D simulation model from Technomatics plant simulator. This is a hull. In the left side there is a hulled experimental manufacturing system, and on the right side we can see the part of simulation. For example, we can see the measured dimension of some parts, and the other information about which part are on belt, and so on and so on. Next slide. Something about data transfer to cloud system. So there is a problems with timing, and also problem with security. Yes. So we have chosen cloud platform Siemens MindSphere, and we use as gateway, IoT gateway, the special equipment. It is called Mind Connect, which is connected to Amazon Web Services Cloud Access. It is not our problem, of course. It is a problem of Siemens, which runs this cloud MindSphere on these Amazon Web Services. What is important for MindConnect? MindConnect, for the first time, it secure the internet connection, and the second one task is that it searches for data transfer from the isolated manufacturing process by a Python OPC server. It is very important. So the manufacturing process was isolated from another internet environment, of course, due to security. So we can say that all critical data transfer from the experimental manufacturing system to the cloud platform was solved by using of MindConnect device, which works like a hardware firewall and isolates the production process from the internet. Next slide, please. Here we can see some results of stored data in cloud. Here we can see in maybe 10 data. Yes, in timelines visualization, there are dimensions, measured dimensions by one of vision system. When I for the first time met the MindSphere, I was not satisfied with dashboards. We had one experimental project with University in Milano, and they prepared for us dashboards in MindSphere, and I was surprised that the quality of dashboards wasn't so as of quality from some companies for example, in Slovakia. And I hope that in the future the dashboards of MindSphere will be better. Next slide. Some results. What is the results of our research? All identification and inspection technologies have their own limitations. Yes, which must be solved before data is stored into a cloud platform. Limitation of RFID technology is that this technology cannot be used for very small parts. For example, screw, washes, and so on, because the tag size is limited by antennaing. In this field, we try to use new approaches, new frequencies of this technology, and we will try in the future also use the RFID technologies for identification of parts. But sometimes it is not necessary. It seems that only the main parts of manufacturing process have to be identified. Maybe it is not economy to identify all parts entering into assembly process. Something about smart vision system. As I said, that we use different vision systems for different purposes, and the most problematic was part recognition. So screw, watch, nuts, and so on. That's why we did a special research in the field. We use convolutional neural networks, and some results of this research are published in 2 papers, which are on the bottom of these slides. Next slide, please. Another problem is delay of cloud platforms. The typical minimal data acquisition time is 1 second. It is not enough for real manufacturing process. So we had to solve this problem using some buffers for data accumulation, and some results of this our research was published in MMS conference in Dubrovnik 2 years ago, I think. Another problem with cloud is that they are primarily focused on data collection and its basic graphical representation via timelines, as I showed in one slide, and data knowledge extraction with critical status alarm, which can be reported daily, weekly, monthly, and yearly. It can be also reported immediately, sending by SMS or email. They are not currently. They are not possible. They are not. It is not possible to store customized 3D virtual digital twin models. So we have to use another databases for this purpose. Very good solution is using Technomatics Plan Simulator, which supports this solution of this problem. So the significant problem is usability of cloud platforms, is the lack of support to store digital twins and this simulation. That's why, as I said, we use the Technomatics Plan Simulation, but combination of Mindsway and Technomatics Plan Simulator is good solution for modeling, simulation, and visualization of real manufacturing process. Next slide. Some conclusions. As I said, limitation of technologies is very important to include this limitation before the designing of digitalization of manufacturing process in the real process in company. As I said, the main limitation is a cloud platform, I think. Yes, it is our opinion. What in the future? In the future, this experimental manufacturing system will serve for further research. Yes, for example, as I said, we wanted to include assembly robot into this process. Now we are in process of buying of Sumy robot from IBB, and I think that it will be very strong support for assisted assembly, and so on. And also, of course, this experimental system serves for educational purposes. Another advantage of this system is that it can be presented for some people from practice, because in Prešov, in Slovakia, maybe in Ukraine, in all countries, there are many small factories, small companies, which they produce some components for example, company in Slovakia, in Czech Republic, and so on. And there is need to have monitoring of manufacturing process. These car companies requires it with supplying of components, and so on, so that this manufacturing system can serve as template for real manufacturing for SMEs. And finally, it is very important basis for further research for assisted assembly. For example, some technologies from part recognition can be easy transferred to virtual reality glasses, and so on, and it will be very useful in the future for further research, of course, of collaboration with practice and other universities. Thank you for your attention.
Thank you. It was a very interesting report, for example, especially for me, because as the mechanical assembly is my educational subject, therefore interesting to listen new ideas, new achievements from this branch. I'd like to ask several questions.
I have my battery is in the end. I will check. I have to power supply. Yeah.
Just a moment.
Just a moment. Just a moment. Yeah. Okay. I am ready.
You're ready. Yeah. Therefore, first question. You said that you can't choose to use standard databases for this system. Why? Can you explain more
about use databases?
Yes, standard, but the databases.
So now we are working. We are working mostly for free open source databases. We use Postgre and time series database Influx for data storage from IoT devices.
I already understood. And another, what are the futures for planning of assembly operation for the implementation of Industry 4.0 conception? I mean the comparison with the existing planning system. What are the benefits? Because a lot of researchers said about benefits about using implementation 4.0, but we as technologists, as we want to know what is the benefits of, what is the futures of this Industry 4.0, especially for assembly production.
The main benefit is quality control. Yes, because you have to online control quality. Yes, it is required, as I said, for example, from big companies. So the continuously in the manufacturing process there have to be quality control. So this quality control it is not possible without monitoring, real-time monitoring, and using the technologies, of course, of Industry 4.0, as I said. Yes, because the result of quality control are finally in cloud system. Yes, which results are available for a server of production and so on and so on. And the second step is, I think, personally, assisted assembly, because complicated products, as for example, in our town is a big producer of gearboxes, and it is not possible to automate this production completely. Yes, there is the human is very important in this process, and this technology can help human to assemble this process. And for example, as I said, virtual reality, glasses, and so on, and other technologies, collaboration with robot, and so on. You know, and that's why the principles of Industry 4.0 are very important to implement in such manufacturing process, such assembly process.
Thank you. And if I understand that, because this means the digital representation, it's very important for implementation of this.
Yes, it is the basis. It is the basis.
Yes, the basis
for implementation of other technologies, especially for now in the stage. It is very important for quality control. Yes, because as I said, small companies in our region, they are under press of big companies to have real data from manufacturing process.
And last question. You are talking about automated assembly production. However, implementing flexible multi-products production for serial assembly is very, very difficult because you said about using the workers, manual workers, is a great percentage in real production, assembly production. And the complex intelligent decision system are needed here, and really we have such production maybe in Japan, maybe in the United States, but for all countries in Europe, such as East Europe, especially for East Europe, is too difficult problems. Yes.
Yeah, it is a complex problem, but our department can solve this problem, of course. Yeah, but we focus it on partially problems. Yes, because for example, part identification is a very interesting problem for automated assembly process. Yes, and it is also very important for half automated process too. So I know experiences with automated assembly process of full system, for example, car and so on. Yes, because we are focused on the partially problems with in this process, and that's why we designed such experimental manufacturing system where we can show the students, of course, how it is possible to solve. Yes, we can show the small companies. We are oriented, as I said, show the first project, H2020, it was project for collaboration with SMEs, with small and medium enterprises. We can show the potential disable as it can be solved, and so on and so on.
Thank you. It was very, very interesting. I hope for future collaboration with our universities, with other universities in Ukraine, and we hope that for next conference you'll give a new report for this theme. Thank you. See you.
Thank you, Juan. Thank you all. Thank you, organizers, for invitation. Yes, and I hope that we will cooperate in the future in some parts of this complex problem. I think.
Of course.
Can I ask a question?
Yeah, Ivan.
Sorry.
Professor Pedal, nice to see you again, and thank you very much for comprehensive research overview of your recent research results. It was very interesting, and I have one question. What is the next? What is the future of manufacturing systems?
Future of manufacturing system?
Yes.
Generally a manufacturing system. Yes, it is very interesting because it's an interesting question, because I was a student. It is 35 years ago. Yes, they told me that in 20 years there will be full automated production. Yes, it is not true. I think that in the future the human will be a very important part of production. Yes, but especially in maybe not checking, because the checking system will be automatically already, but in planning and improvement and so on and so on. But I think that full automated production will be maybe in the next 20, 30, maybe 40 years. Yes, because it was not true as they told me when I was a student.
Thank you. Let's get over to the next report, isn't it? Yeah. It is management perspective in Industry 4.0. I said that all our reports in this keynote session will be dedicated for this problem. The speaker is our very good friend this is Sławomir Luczyński, Calcy University of Technology, Poland. We are glad to see you and at our conference again. Please start your report.
Good morning and to everybody, to my dear friends from Odessa, Sumy, Łódź, and Kharkov. I'm happy to be again. That's my honor and privilege to be keynote speaker in this conference once again. A little bit information about me. My name is Sławomir Luściński. I am the assistant professor at Kielce University of Technology at the Faculty of Management and Computer Modeling. Actually, I'm also the head of the Laboratory of Modeling of Intelligent Production Systems. I'm very happy to have a rare occasion to hear the very rich presentation of my colleague Professor Jan Pittel, because it seems to me that we'll have in future a lot of cooperation, I hope, about the assembly system, why I'll tell you in a moment. So the first couple informations is about Kielce University of Technology. We are situated in large 22 hectares campus in the city center. Some of your colleagues have a possibility to visit us. I hope that in the future it will be more possible than now. We have the very compact campus. It gives us a great possibility for interactions and communication between the faculties. We have now the 5 faculties, the civil engineering and architecture, the electrical engineering, automatics and computer science, environmental engineering and geomatics, mechatronics and machine design, and my faculty as the management and computer modeling. The brand new complex, which is have been just opened a couple of weeks ago, and it was announced for a couple of years. It's a scientific and implementation center for intelligent specializations of Świętokrzyskie region. That's a very big step into close cooperation between the university and industry. This brand new building consists of, in this brand new building are placed 14 laboratories. 6 of them are brand new. Rest is very well shifted with the equipment. The main goal for this CENVIS center is the strong cooperation with the industry. So when it comes to my laboratory, which I mentioned before, Laboratory for Modeling Intelligent Manufacturing System, I think it would be interesting for Professor Jan Pittel, because we decided not to build up from the scratch assembly system. We just buying industry standard ready system on which we can do experiments. We start with 2 projects. The first one is about the digital twinning and following some ideas which were presented by Jan Pittel. The second project, which is under design and will be ready in a couple of days, I think. We are trying to obtain the grant for it, is about the predictive maintenance. And the third part of research will be on production planning, and we intend to use in both last areas, so in maintenance and in planning, cognitive calculations or artificial intelligence or whatever it means, to support the better results in this area. So that's the point of our interest, points of our interest and my engagement. I personally, I am involved in computer modeling, especially with 3D and simulations. Also, it concerns of my interest in applying the IT technology to the management and production. So that's the short presentation of the Kielce University of Technology. And now let's back to the presentation. The first slide, sorry, it's I have the problem with my part. Yes, okay, but just in a case I have the, okay. So the first statement and the first screen is about the new approach which is hidden before the term of Industry 4.0. What I mean, the approach is mainly based nowadays on some kind of holistic vision. It's not the first in the history holistic vision of the production, but I think it's more holistic than ever before of the technologies which are internally presented by the Professor Pittel. I mean, that's the Internet of Things, which is, in fact, the element of applying the Internet technology into the control systems. What is going now? The pyramid, which is vivid here, is the classical model pyramid of automation, which was introduced by the ISA 95 standard. It's a long time ago, and it talks about a hierarchic model which was created just for present the idea of manufacturing execution systems as part of the control system or computer supported manufacturing in the company. What happens now? That's the process of removing all of the layers which were above the real-time and critical systems, remove them or move them to the cloud. Exactly, it means that we are talking about the two concurrent processes. The first one is we are trying to move the management system to the cloud. So that's the kind of centralization. And it is very important when it comes to the discussion about the integration in value chain, because we want the cooperation between the companies and exchange of the data. So the cloud computing is very suitable for this. From the other side, we need, for the real-time critical applications, we need a solution which means the smart devices or smart sensors. So we're trying to empower with the processors, with the memory, with the software, the end of the network. So it calls the, we use the term edge computing. Edge computing is one of the new technology umbrella, which is introduced a couple of years ago. It means that we are spreading, whenever it's possible, into the production system, the embedded systems. So very powerful units, very clever, smart, with for instance, we talk about the Siemens. Siemens use the PLC system with built-in artificial intelligence or statistical calculations units for condition-based maintenance and recognizing the failure of the machine or the symptoms of the failure of the machine just next to the sensors close to the machine. It's on the lower level. But sometimes we need much more power in calculations, much more infrastructure in the sense of the, for instance, supercomputers or something like this for the cognitive calculations. So that's a very convenient to move a lot of the part of the management system into the cloud. So what is interesting in this holistic theory of production is the process of the convergence. So we are trying to use the same protocols, the same standards for exchange of the data. For instance, it was mentioned in the presentation of Professor Pittel, OPC-UA standard as a standard in industry for exchange of the data between the SCADA PLC or the ERP or MES systems. That's the problem of creating the lake of data. It's a kind of database which are designed with unstructured systems dedicated to the big data analysis. So the convergence means that we are using a lot of standards which are common for IT world and the control systems well known in production. So that's the technological point of view when we talk about the integration. And the next slide, please. There is a significant change in narration about what is the Industry 4.0 as a concept. When it was introduced in 2011, or we should rather say 2011, it was more about the technology. Around this concept, the Germans, which are in fact the authors of this term, around this concept, they create a coalition of the industry biggest players and the government and the universities. Nowadays, after almost 10 years, they extend this definition and they point out very specifically that Industry 4.0 is the process of innovation and transformation. It's not, in fact, only about the technology. That it is a very important shift and change. And it's partly answer to as a solution of thinking about the Industry 4.0 to the discussion which was happens just before my keynote speaking. We talk about to which extent we can introduce the Industry 4.0, the full automation. It's not the case because Industry 4.0, in fact, it's not purely talk about the full automation. Industry 4.0 is a little bit more complicated term, and it's nowadays seems to be much more about management than ever, much more about the innovations, about the qualifications, customer-centric system, etc. And the technology, which was so beautifully presented, for instance, by Professor Pittel, it's a driver, it's the mechanism, it's a necessary tool to implement those ideas. But we should have a bigger picture about what we are doing for those automation or semi-automation system, and what is the purpose and the strategy on the market when it comes to the conclusion that we in fact need a market, need the customers to sell our products. So next slide, please. We have some models which we can present about the Industry 4.0 implementation. This model is interesting, taken from the one of the articles from the Germans. They talk about, and it's not only them, but that's the just example, we should talk about two kinds of integrations, the horizontal integration and the vertical integration. The digital transformations which are involved in these processes of the integration are crucial and requires a lot of innovations in this area. But when it comes to discussion, what is really Industry 4.0 implementation, you can see that there is nothing special about the robots, about the industry, Internet of Things, about the lot of technologies which are involved, in fact, in one only rectangle, one block, planning, developing of technical solution and implementing Industry 4.0. Yes, that's very true. Without this technology, we are not able to do it. But with this technology, we need also a lot of the competency, a lot of the management efforts to put it into the working system. What we can see and is visible in these days' presentations is the environment. The environment which involved not only the business partners, cooperations, cooperated companies, but also the educational sector, the government sector, the research sector, if it's a little bit distinct between the educational and research. So there is also the very significant role of the associations which are created by the companies, for instance, to support the standards which are the core element of the engineering business. Without the standards, there is no engineering. That's the simple. So the associations of the companies support the standards. For instance, over 500 German companies support OPC-UA standard, and they create associated around this to maintain this standard consistent and working for the industry. So that's the Industry 4.0 issues, how to implement this idea, because when it comes to the engineering, better or worse, fast or slower, we can do it. That's the classical engineering problem. But when it comes to work as a market entity, a company which implement Industry 4.0 concept and successfully works, it's not so obvious. There are some data from the researchers, for instance, McKinsey. It's an expert company. They created a report, they done the report 2 years ago, and they point out that 70% of the projects which were dedicated to the Industry 4.0 failed. In last 5 years, it was 2 years ago, so I have no data about last 7 years, but that's very significant. So this ratio of failures varies between the countries and the branches between 70 and 90%. And I don't think that these failures describes the engineering failures about the automation, about the computers or robots or whatever we say, because it works. The question and the issue is about how to maintain those new business models, how to maintain those new ideas in the big scale. So that's the main problem. Please switch the slide to the next. There are some from the taken from the practice. There are some implementation principles which are presented here on this slide. I think the most interesting which we can point out is first is the qualifications, because as the report said, the future task which are designed for the employee in Industry 4.0 needs the future competencies. That's the very big problem with the universities, because we have now the situation in which our laboratories should be a little bit ahead of the industry reality. It's a very, very pricey process, and it's very, very hard work to do. That's why we decided to not to develop as a kind of prototype the assembly system as a physical model of the real production system. We want to take it from the industry to make sure that we have time and resources to be a little bit ahead of the industry. So the industry has very good competencies in automation, control, some aspects of technological solutions. We are not required to do it again as a prototype. What is new for the industry in this Industry 4.0 concept is the advanced IT implementations applications. So the cloud computing, the edge computing, the artificial intelligence, the automated identification, virtual reality to support the maintenance or the monitoring of the production. So those pieces of technologies and those areas give us a margin of the future of the industry, and what is reality we should buy without hesitation that okay, maybe it's better to build from the scratch. We decided to took another strategy. So what is interesting about that future task of employee? The problem is that I have done a research 2 years ago, which was aimed to establish the gap between the expectation of the students, the knowledge which they declare as they have about some aspects of the modern technology in industry. And it was very interesting that they have, first of all, very optimistic view of their qualifications. When it comes to description, what they have been taught or what they have learned, and they were very pessimistic about some aspects of their education as usable in the future, in the practice. So that's the question of, I think, the information mess around them. They don't really truly recognize what is needed as a knowledge, as a skills for their future occupation in the industry, and they have no trust that what we do for them is some elements of their future competences. That it's very important to make them internal, our visions, to make them believe that what we do on those conferences, in our research, it's not the theory, because that's the sometimes very strong discussion between the students and us during the lectures that, okay, what we are doing is very interesting, but it's only the theory. The practice talks something different. It's not really true. The question is why we should follow. I always ask the students, what have you seen in your company when you do the internship, when you do some practicing exercises? What have you do? How can you describe in the language we put in your head what you have seen? So don't give me a relation just like any other people do. I have been in factory, a big machine I saw is very impressive. Whatever, it doesn't matter. You should describe it in the terms we put in your head during our lectures. And they are surprised after this switch, that they have and see much more. So when they recollect the information from the past and trying to use the proper language, everything seems to them much more clear and much more rich in details and much more close to the ideas we described them during the lectures. So that's the problem of teaching the qualifications and transferring the qualifications to the future employees. The sharing knowledge is not so new. We talk about it since, I think, end of the 20th century. So that's the is in intra-organizational and extra-organizational digitalization. It's the point 5 and point 6 on the left part of the slide. That's the question, because we need a strong infrastructure, the public infrastructure, to decrease the cost of implementing, for instance, the cloud computing or access to the data center. What is significant in Poland in the last couple of months is that the Google company and the Amazon company announced in the beginning of the year that they will create the big data center. They have some offers for the industry about the cloud computing or using a lot of the services which are available on their platforms. So it means that it's a good news, because it means that we have just passing the critical barrier for implementing the wide digital infrastructure for the whole industry. Of course, it's not the question only. It's not only the question of the technology. It's also the question of the mentality, because the cloud computing seems to be, for many managers, seems to be unsecure. For many managers, it's a big risk to avoid flow of the company data outside the company and make them potentially available for the hackers or for the industry spying or whatever. So that's another issue: how to preserve the security of the data, how to preserve the reliability of the systems which consist of the cloud computing component. That's also question of some mental barriers which are still we can still observe in industry. But there is a lot of changes in last half a year, especially due to the pandemic process. We observe there is a lot of things which have changed about the myths on IT technology. So the distant working or learning becomes business as usual, and it means that we have the technological competency and sources. We have some mental barriers, we have some organizational barriers, or the mental barriers. It was past. So I think the next step will be accelerating the process of implementing the IT technology in the industry, because of the passing or breaking down some paradigms or some stereotypes about this. The next slide, please. There is another problem, another issue which comes on agenda when we talk about the management of the industry, which runs the concept of Industry 4.0. There's a business model innovations. Business model innovations describe, let's say, the business model. What is it? The business model is the way how the company collect the money from the customers. So what the people pay for, that's the business model. That's simple. It's all about the money and the profit. So we have some trends on the market we can observe. There are some researchers which trying to systemize this era. So we can say that we have something which is called super archetypes, or the main archetypes of the business model innovations in Industry 4.0. The first one is focused on processes. Production as a service, or mass customization, mass customization is known for more than 20 years. Just with the start of the internet, crowdsources innovation is something which use the legacy of the open innovation model, which we also know from the beginning of the 21st century. Production as a service is also well-known model in some industries. So that's kind of the archetype we can see name integration, which is focused on the processes. The second archetype is servitization. So servitization means that we're not buying something to do, we buying results. For instance, there is a lot of problems in the modern industry about introducing the robots, because buying the robots, it's a huge amount of the money, and the return of investment from this robot is very long, very small, and very long in time. So how to support the automation and robotization? Of course, there are a lot of companies, especially for instance in Germany, which sells motor hours of the robots. So I pay for the just work time of the robot, and that's all for I pay for. So that's the kind of outsourcing which is quite interesting. There are some changes, for instance, in the Polish research which are undergoing on the universities. We sometimes decided not to buy equipment. We just rent the equipment for 1,000 hours or 500 hours just to use in our process, and that's all. We don't need buy to it. Sometimes for the academia is a dead-end way to buying a robot, because we pay a huge amount of money for something which will be modern for next 2-3 years, and after those 2-3 years the next generation of the robot will be introduced. So it's better to pay for a service than for a real ownership of the product. So that's the Industry 4.0 models, in fact. And the last, the third one, the super archetype, is the expertise as a service. When we talk about the cloud computing, for instance, the system we want to develop with the cooperation of the industry in the next couple of years is the system about the predictive maintenance platform. And this predictive maintenance platform consists of the three layers. The first one is the data discovery, the second is the cognition layer, and the third is application layer. The cognition layer is most costly because it's a lot of software, of data bases, a lot of informations which should be used for the deep learning or machine learning as well, in the process of creating the smart solution for the predictive maintenance. So it's better for the company to pay a subscription, which is the way to access the computation power of the supplier of the solution. That's the first. The second, and it's a question of the scale in costing. So if I am only one of the hundreds of the customers, the subscription is not so pricey for the particular company. The second benefit for the company which use the subscription through the IoT platform or cloud computing is that we can use the patterns, the specific patterns from many branches which were recognized during the machine learning, and we are not only the supplier of the cloud computing infrastructure or the algorithms, we are also the supplier in this case of the general knowledge about the maintenance of different types of the machines, and it is created during the process of serving for the company with such a product. So that's the very interesting model of cooperation, which in fact has some new ideas. For instance, what I described before, it's just the synergy which is behind this approach. So that's how we can describe the Industry 4.0 business models. And finally, when it comes to the next slide, please. Finally, when it comes to the implementation of the Industry 4.0 in industry as a concept, as approach, I decided to use, there is a lot of models, a lot of academics and a lot of experts creates own models for maturity models to describe the requirements for the particular company, what they should do as identified gaps between the maturity level they want and the current state of the organizations. I decided to use the PricewaterhouseCoopers Germany model because it is grounded in the German industry and it is grounded in the experience of this company cooperating with the branches which are involved in the process of implementing the Industry 4.0. So this model, as you can see, is much more about the management than technology. Technology is only the means and tools. So we talk about some main criteria which are considered to be research in the company. So what we know about the business models, product and service portfolio of this company. So that's the main point and the starting point. What is about the market and customer access? What is about the value chain? I mean the supply chain and interactions between the cooperated company, how the processes are implemented, if they are open for our cooperators. What about the IT architecture, etc., etc. So there is nothing about automation, robots, or any other pieces of technology because they are de facto standards. We know that we can do it. That's the question. We do it smarter or less smarter, better or less better. So as I said in the beginning, the Industry 4.0 nowadays is mostly about the how to proceed with some part of mega trends which are observable we can see on the market and in the development of the technology, how to maintain those mega trends and incorporate them into your business and create something which we can call, okay, we are the digitally transformed company, and we can say that if we are the production company, this digital transformation give us in the end the vision of the Industry 4.0 production. So there are of course the maturity levels which describe what is. That's the fine conclusion, because in the beginning I say that Industry 4.0 is about the vertical and horizontal integration, and you can see that that's the main point to do the distinction between the level 2 and level 3 in this maturity levels. We are the vertical or we are the horizontal collaborator, and finally we are the champion because we do all of these things. So we should always remember about one thing. When there is sometimes a discussion about where management belongs to. Many people believe that management belongs to economic science. I particularly believe that accordingly to the history of the scientific management, production management is the core knowledge of the management at all, and it was developed by the engineers in the beginning of the 20th century, just for the purposes of shifting the efficiency of the manufacturing in the beginning of the 20th century. The same story seems to me happens now. The management need engineering because we are the next. Everybody talk about the technological revolution. It's the same, in fact, when we talk about the to which extent it influences our society, social economical systems. The same happens now after over 100 years. So engineers should be involved in management as they were 100 years ago, because this involvement 100 years ago bring us enormous developments in every area of our life. So I think we should be ready to support this as engineers in the 21st century. Thank you very much for your attention.
Thank you. Thank you, Slawomir, for interesting report and your fresh and interesting viewpoint for so difficult and so expensive, as you said, that problems for implementation this conception in mechanical engineering. I'd like to ask several questions. First of all, what are the futures for the implementation of the idea of product life cycle support system in the Industry 4.0 conception? What are the futures, main futures?
Without PLC, yes, okay. So the PLC, which is supported nowadays by the in fact, we need a PLC which is implemented in the computer integrated manufacturing science, creating the idea of the product to the manufacturing through execution of the CNC code. So that's the one flow of the data, which are that's the value chain from the idea designer to the manufacturing worker, operator of the CNC machine. And this flow of the data is supported by a lot of tools. What is interesting in PLC and what is very important, that due to the idea of the digital twinning, which was presented by the Professor Jano Pitel, we should implement ability to prototype a topology, for instance, of the manufacturing system and do the simulation through the digital twinning, how it will be works. So it's a question of extending of the PLC, which is supported by the lot of tools now, from the support for the particular design of the particular product to design and a technology which is involved in manufacturing of the so technological abatements which are operations which are involved. We should extend it to the simulation to the planning and simulation of the particular production system, which will be involved in manufacturing of the product. So that's a big shift, I think, in the future. That's one. The second one, which is strictly idea which belongs to the Industry 4.0 model, is the idea that we should, when it comes about the mass customization, when we talk about the quality as a voice of the customer, and finally, when we talk about the customer-centric activity of the company, which means that we are fully oriented on the market and their needs, it means that we should have a lot of data from the market, which should be incorporated during the process of designing, starting from the concept for the technical designing of the product in the PLC phases. And that's the very interesting. We should introduce concurrently two processes of designing. The first process is designing the technology and the construction and technology, and concurrently we should design the business model. The classical example of designing concurrently with involving the business model requirements is, for instance, the evolving product on the market. It's a computer printer. Many years ago, we believed that companies which produce the computer printers, they are profitable because they produce the computer printers. It's not really the truth. When it comes to the discussion about the structure of the profit, you will see that most of the profits are from selling the operational material for those printers, not from selling the printer itself. That's the business model. So it's changed the way of designing. The business model is the one of the element which should be involved in designing the machine. For instance, if you want to sell, if you want to use Industry 4.0 model machine as a service, for instance, you should preserve a lot of assumptions. You should use a lot of assumptions about how this machine will work in the different environments, how we can monitor them, how we can serve them, what is important to support the continuity of the operation for this machine in particular environment, etc. So that's the very interesting and rich era of research and I think interest for practitioners, how to introduce the future business model for the currently designed product. That's the, I think, one of the challenges. Not only the one, but it's crossed my mind now.
I think that this approach may be called as computer engineering. Yes, approach. Yeah. As a conception for connection, design, production, manufacturing, and the operation properties for support, like cycle support. Yes, isn't it?
Yes, I think. Another, for instance, when we talk, we have some skeptical approaches to 3D printing as because it's the question of the scale of the production. But sometimes we should consider that it's much better to use the 3D printing to do some replacement parts in the world somewhere than to produce them and storage them in the warehouse, because it's sometimes costly, etc. So that's a lot of things. Yes, I agree.
Yes, of course. This is a so complex problem that we can't answer for this question, for all questions for one report. But your point very interesting, very fresh. Thank you,
Thank you, Vadim,
thank you.
for supporting.
Mam nadzieję, że wkrótce się zobaczymy.
Myślę, że tak. Ja bardzo za Odessą tęsknię, a w Lwowie jeszcze nie byłem, więc tym bardziej muszę pojechać.
No, ja powiedziałem panu, że to trzeba było przyjechać do Lwowa na konferencję nasze.
Trzeba przyjechać.
Przepraszam.
Mam nadzieję, że tak się stanie. Bardzo
Thank you. Unfortunately, our session has come to finish. I thank all the participants and first of all for speakers. I'll see the next session after a short break. I also hope hold a conference in Odessa next year. I wish you all good health and good luck. See you. Thank you.
Thank you very much.
Thank you very much.
Thank you, Jano.